Hello, everybody. Hope everyone is safe and healthy. It's a sweltering hot good evening for Southeast Asia, India, Middle East, and the Gulf states. It's good afternoon to those of you joining us from Europe, Russia, CIS countries, East and South Africa, and top of the morning to all of you based in the Americas. First of all, a big shout out and a thank you to all of our partners across the globe for promoting our webinars, because if it wasn't for you, we wouldn't have an audience. So today we will introduce the pinnacle of our Sound United products, our Classé Delta flagship series. And joining us today is our very own lead visionary, Dave Nauber, our Classé brand director for a special tour in his home in Connecticut. So welcome and thanks for joining us, Dave.
Thanks, Frederick. Very happy to be here. Looking forward to it.
And our host today is Phil, and he joins us from his fancy new office in Carlsbad, San Diego. Over to you, Phil.
Yes, welcome to my dungeon. Good morning, Dave, or actually is it afternoon for you?
Still morning here on the East Coast of North America.
So, Dave, what would be nice is for you to give us a history or just a brief understanding of Class A as we get started, because some people may not be as familiar with the brand as we are. So, would you like to do that?
Sure. Yeah, sure. Classé is a French-Canadian brand founded near Montreal, Canada, and it started with uh, an audiophile named Mike Viglas and a very talented engineer named David Reich. David had been building amplifiers in his home under the brand name Ellison, and this was in 1979. It was very common at that time. This is, you can imagine, it's pre-digital days. It was common for high-end electronics brands to start in this very small way where someone would build products in their house. In fact, that's the way Marantz started many years before. So David Reich met Mike Viglas. Mike was a fairly successful businessman who happened to be an audiophile, super passionate about music and about sound quality. And Mike liked David very much. He invested money into the company. They named it Classé, so it began in 1980. And off they went. The first product was a stereo amplifier, 25 watts per channel, and it operated in pure Class A, hence the inspiration for the brand name. The accent on the E reminds you also that it's French Canadian. Mike ran the company. I joined the company in 2002. And the next thing you know, we become part of Sound United in January of 2018. So that's what brings us here today. I was attracted by the passion for audio, for music, and the attitude of the people of the company. Very inquisitive and hardworking. Just loved everybody there. So that's how I came to be here. And here we are at Sound United.
Now, there is another benefit to Sound United and Classé kind of teaming together, and some of that has to do with the manufacturing. Can you talk about the fact that where Classé will be built?
Yes, it's an important part of the story because when you look at the history of high-end audio, you see a gradual transition of the products. The products introduced a digital circuitry, a digital control, and the way that products are built has evolved over the years. The notion of having a very small team and building everything by hand with a soldering iron really is not. It's really not the way you want to build a high-end product today, because certain things can be built much more consistently if you combine both handwork and things that are done by an automated process. So that requires a bit more sophistication. We've transitioned from a Montreal-based manufacturing. For a while, as we were owned by Bowers and Wilkins, we had products built in Zhuhai, China, which was part of a Bowers and Wilkins factory. And today we're in Shirakawa, Japan, at Shirakawa Audio Works, and it's in northern Japan. It is a very sophisticated production facility, one that allows us to execute on our designs at the very highest level. And I would say one of the most important things is not to be able to build a fantastic sounding amplifier or preamp. It's to build hundreds of them and to have them all be exactly the same. And that requires very sophisticated production capabilities, the likes of which nobody, in my opinion, competes with Shirakawa Audio Works.
Yeah. So one of the things that we stress a lot, and we've talked about in many of our sessions, is the fact that Sound United is a group of brands. And a lot of times it's the smaller brands that it's the little things such as Wi-Fi and digital and those types of things that Dave just talked about that require a lot of engineering and a lot of engineering resources. So a lot of times if you look at it like a car, the exotic cars, it's the electrical systems that fail, because they just don't have the engineering resources to put behind the windshield wipers and the air conditioning and the navigation system. So if you look at like Volkswagen, which owns Lamborghini, the quality of Lamborghini has went up substantially because now the Lamborghini engineers can focus on the things that make it a Lamborghini, and they can go utilize the manufacturing and some of the engineering resources to do the little basic things that you would expect from a car. So
Phil, that's sorry to interrupt, Phil. That's a really important point, and I'm glad you brought it up. The ability to produce the best sounding audio equipment doesn't really have a lot to do with HDMI, for example. So all high-end electronics companies that employ HDMI buy HDMI from somebody else. The fact that we get HDMI from a tier one company, it's we're getting it from the best. It means we'll get the not only quality but also the latest technology. So super important to us.
Yes. So the goal is to give you ultra high performance and consistency and reliability. And by Sound United being together with Classé, you get all of that. And Shirakawa Audio Works, by the way, is also where all of the high-end Marantz and Denon pieces are actually manufactured as well. And like I said, it'd be difficult for a small brand to get into a factory like this. Dave mentioned that before, because of the amount of units that they're selling or that they're building, but because it's part of our family, the several hundred units that they will build it's worth our time to retool and engineering one of our lines to build that product versus another trying to outsource that to another high-end Japanese manufacturing facility. So there's lots of benefits to this being built in Shirakawa. So we wanted to kind of really stress that. Now, Dave, the next thing you want to talk about is kind of the idea, the goal, the soul behind the brand. So we'll get into all of the technical stuff a little later, but just the overarching position. Why, where are you trying to live, and what is your overall goal to do all the things that you're doing in Classé?
Well, I view the process as being analogous to climbing a mountain, where our goal is to get to the top of the mountain. The top of the mountain represents the most neutral sounding electronics, electronics that do not editorialize on the creative vision of the artists who made the recording. We want to have products that perform within a system in the best possible way. So an amplifier that can be connected to any loudspeaker you like and work effortlessly. An amplifier that can be connected to any preamp you like and not place an undue demand on the preamp. So we like all the systems to work as neutrally as possible. And there are many different ways to try to get to the top of this mountain. And you see different electronics companies choosing different faces of the mountain to climb. What I find is that many companies choose a particular face of the mountain and they never deviate from it. It's one technological idea that they just keep flogging forever. What's different about Class A is I think of our company as being more open-minded. As things evolve technically, we have to stop periodically and say, are we able to advance in this direction? Or if we went to a somewhat different side of the mountain, could we get higher at an equally or more affordable price? What is the best way to do something? So it's this inquisitive nature that I think is a real important part of our philosophy.
Yes, yes, and that makes big sense. The other thing too that idea of looking for a better way to climb the mountain is one of the reasons why nothing looked like why a Class A amplifier or preamp looks different. So there's basically three things that normally that stood out to me from talking to you. Number one, it is built like a tank. Number two, it is the design matters. And the last thing is, or the most important, number one, is it's about getting the best sound possible with as little compromises as humanly possible. Because even at this price, you're still going to have to compromise a little. But the thing is, being at this price means that you can be a lot more demanding about what this amplifier can do. So, and it's funny, it's almost like a form follows function. We're going to talk about what's inside of this amplifier and why this amplifier sounds so good. And as we talk about why it sounds so good, it'll explain why it looks like it does. So let's go through that. So the first thing we want to talk about when we talk about the amplifier is the sound, because sound's the most important thing. And the name Class A means that is derived from what, Dave? Class A. Can you explain what that is? Because we a lot of the listing you're going to be listening to when you play a Class A amplifier is going to be in Class A. So can you explain what Class A is?
I will do my best. I will do my best. There are many different classifications or classes of amplifier design, and all have certain strengths and weaknesses. The most common for higher end audio applications is a design called Class AB. And like the name implies, it's a kind of a combination of Class A and Class B. Class B is a very high distortion solution, but it's very efficient. Class A is the lowest possible form of distortion, but it's very inefficient. So Class AB is a combination that makes pretty good sound, pretty low distortion, and pretty efficient. We're willing to give up some of that efficiency in order to get a little bit higher up the mountain. We want to have the purest form of amplification. And what Class A implies is that both halves, there are plus and minus you can think of this as plus and minus transistors, or plus or minus halves of the amplifier. They both push and pull together through the entire cycle, through the entire plus and minus portions of the music wave. And so there are no distortions when you hand off between the plus and minus sides of the amplifier. And this occurs for a very large signal size, 35 watts in the case of the mono amp, and 12.5 watts in the case of the stereo amp.
Yeah. So the way that you explained it to me, and I thought it was brilliant, is think of it like a relay race. So a Class B amplifier, one guy's running at full speed, and the other person's just standing there waiting for the baton. And then all of a sudden, as soon as when it's time to hand off the baton, one has to slow down and hand it to the guy that's sitting there, and then the other guy has to take off. Number one, that time where they slow down and to do the handoff, think of that as distortion. It's not the best way to do it. AB would be it's like a traditional relay race. You're running, and then the other guy sees that you're coming, and he starts to run, and then while you're both moving, he hands off the baton. So that makes it a little bit more. Makes it a little bit more efficient. But you could drop the baton, or it may not be. The speeds may not be exactly matched. So what Class A is you and I are both running around the track with the baton together the entire time. Now that ensures that the baton doesn't get dropped. There's no problems with the handoff, but the problem is we're wasting a lot of energy. And Class A is a great amplifier design, but it's not efficient. It's almost like like you have a car. It's like the car's throttle is stuck to wide open at full speed, and you're regulating the speed using your brakes. Now, that's not very efficient. So Class A takes a lot of power and generates a lot of heat, which is why you don't see big, massive Class A amplifiers. And even the fact that this amplifier runs in Class A with as much power that it does, and it's still this small, has to do with Dave's design. So Dave, why don't you talk about how much power comes from Class A?
Yeah, so that's an important point that when we think about the inefficiency of Class A, it becomes very impractical if you wanted to build an amplifier that would deliver all the power under every condition, no matter how momentarily, to deliver all of that power in Class A. So what we want is a big Class A envelope, in this case 35 watts per amplifier. And most of your listening is done well within that range, but from time to time you require a lot more power. In the case of and that's for dynamic peaks of various kinds, especially low frequency. These amplifiers can deliver 300 watts at 8 ohms and 1,000 watts at 2 ohms. So they have plenty of power regardless of the type of speaker that's connected, and you're the power you use will be typically far less than the amplifier is capable of delivering. So the amplifier delivers a kind of an effortless sound. It doesn't strain when you play music at a very high output level.
Yeah, and that's one of the things that I got from it. Clean and effortless. So the majority of the music you're listening to is in the cleanest, purest way of making amplification. But then regardless of whatever speaker you throw at it, how much power you need instantaneously, it's there and it's absolutely effortless. Now people look at it and they say, well, Dave, 35 watts, or even if you look at the Delta Stereo, 12 watts per channel in Class A. Well, how much of that is that really enough for most of my listening? Now we do it like there's a meter on the front. Can you talk about how you can use that meter to evaluate that?
Sure. I think the meter is an aesthetically pleasing addition to the amplifiers that we build, but it does have a somewhat practical purpose, which is that for people who are interested in determining whether or not they're listening more or less in the Class A region, you can put some music on and turn the volume up to the point where the pointer is vertical, and you can see that the meter reads 3 watts at that point. You'll be amazed at how loud a real 3 watts of power will drive your loudspeakers. So that's 3 watts at 8 ohms. If you happen to have a 4 ohm speaker, it would be 6 watts, but it's still well within the Class A envelope. And that helps you understand how virtually all of your listening will be in pure Class A. You see the next mark over is 30 watts, and I guarantee you'll rarely be listening to music up at that level,
Yes.
because you'll drive people away. It'll be so loud.
Yeah, and we've done that. We actually people come into like Dave's room and he's running a pair of Magicals, or you walk into maybe like a Magnolia Hi-Fi and they're running a pair of Kef Blades, or someone has a pair of big B&Ws on here, or a pair of Wilsons on here, and they're like, oh my God, the bass is just amazing. The dynamics are just amazing. And you go look at the meter. And you walk up to the meter and it's doing 3 watts, and you say there's 1,000 watts in that box. But what you're getting, what we're utilizing right now is 3 watts. Because we always want to stress, you're not buying a wattifier, you're buying an amplifier. And the reason an amperage is what keeps control of that woofer or those speakers and pushes it out and pulls it back. And the more current you have, the more control you have. But when you add more current, the box gets heavier. So a lot of times, that's one thing that Dave we talk about simple demos you can do with these things, Dave. We talk about just current the lift test. You want to talk about the lift test?
Sure. Yeah, you know, we like every other manufacturer must obey the laws of physics. There is no shortcut, and if you want an amplifier that does deliver a lot of power, it happens to require a lot of copper and aluminum and various materials that just make it heavy. So with all linear amplifiers, uh, ones that don't weigh very much simply won't be able to deliver very much power, or if they do have a certain amount of power, they'll deliver it for an extremely short period of time. We use a custom transformer, for example, in the Delta Stereo, which is um, a very heavy and expensive piece of a very heavy and expensive component. It weighs 37 pounds.
Hold on, Dave. Hold on,
Sure.
Dave.
Yep.
I have it right here. So this is the power supply that goes into a Delta Stereo, and I had to put it on a shelf because I had it on the floor last time, and even me, I could barely pick this thing up. Now, how much wire is in here, and how long does it take to make this?
There are over 540 meters of copper in that transformer, and it takes over 6.5 hours to wind. So it's just simple physics. If you want to deliver 1,000 watts at 2 ohms, you have to have the copper to do it. Some people have asked, why do we have 300 watt rating on this amplifier compared to the last generation, which was 600 watts? It seems like you're getting less power for more money, and the difference comes in that 2 ohm and even the 4 ohm capability. We really have the ability to deliver a lot more power continuously at the low impedance compared to the previous generation.
Yeah. So just to put it in perspective, okay, how much did you say this transformer weighs? What you said? How many kilo did you say? You think
yeah, it's over 17 kilo.
Yeah, so it's over 17 kilo. That is the equivalent. The power supply weighs more than a 11 channel high-end Denon receiver. So think about that. One component weighs that much. So when you talk about lifting one of these amplifiers, I know I've had to kind of shuffle these things around. There's a lot of physics going on in there. Yeah. And now the other thing that's important, Dave, about the fact that you were talking about the fact that the power doubles as impedance goes down. Talk about the fact that speakers are not 8 ohm. And so that's an important one as well.
Yeah, so loudspeakers are typically rated as 8 ohms or 4 ohms, and it's a bit of a simplification, or you might even say kind of an extreme simplification of how they look as a load to the amplifier. When you put music, anything that's changing in frequency through the loudspeaker, what you find is that the impedance, which is something like resistance, it will vary. And it might be 20 ohms at one frequency, and it might be 2 ohms at another frequency. And so you have to make sure that you've got enough power at 20 ohms and at 2 ohms. And that's an important part of the design process. The ability to deliver a lot of current helps you to sustain power delivery into really low impedance loads. And that's why, for example, when we started the design process for these amps, we were thinking of the B&W 800 series, which spends a good bit of its across a 70 hertz to a 1 kilohertz. The big 800 series is below 4 ohms. So you really want to have a lot of power, a lot of current to effortlessly deliver energy into that kind of a load.
And it has all this Class A power, which we know generates a tremendous amount of heat. And we have all this current delivery in this itty bitty box. Now, for it's not itty bitty for what it's having to do. It is amazing how much is going on in here. So when we pull the shell off, we climbed the mountain different. This does not look like, when you take the case off, any other amplifier when you remove the lid. And later, Dave is going to remove the lid on his live, so we can go in and explore some of this stuff. So we've already talked about that massive toroidal power supply that is sitting in the front, and we'll talk about even the way it's positioned a little later about what the benefit at it is. But the main thing is we talk about Class A power generates a tremendous amount of heat, and you have to disperse that heat. So you have so most people would have to use a giant amount of heat sinks. I had a little 35 watt Pass Lab Class A amplifier, and it looked like a porcupine. There was so many heat sinks on it. It was a dangerous weapon. So, but this amp does not look like that. So let's talk about how we got this design. And a big part of that is what Dave likes to call the icy tunnel, or what we call the icy tunnel. So Dave, can you talk about the icy tunnel a little bit, and then we'll pull the lid off of yours and show them what it looks like. Actually, we can pull the lid off of yours right now and show them the icy tunnel inside of your amplifier.
Well, I'll suspend the drama just a little bit. First of all, let me take let me take a little bit of issue with you emphasizing tremendous amount of heat. I don't want people to think that this amplifier is completely impractical for a warm environment, warm climate regions of the world. It's the kind of thing where if you tried to build a 300 watt amp that could do 1,000 watts at 2 ohms and have it be all Class A, that is indeed going to generate a tremendous amount of heat, because it's going to put more than 1,000 watts of heat into your house
all the time.
Each amplifier all the time. So this amplifier is putting, it's the 35 watts of heat into the house. It's like having a light bulb on. So it generates heat, and it is a problem if you try to deliver too much power in Class A, but it's not a crazy amount. So just it's sort of like a practical thing. Now,
the other thing I wanted to mention about that, Dave, is I think your design actually makes it a better solution for someone in a hotter climate, because it's not just utilizing what they call it, convection, which is like if you're to remove the heat from the amplifier, and that's why the icy tunnel. So actually, if you live in a hotter environment, or you want to, like as Dave say, rack mount it, which is what I would love to do with these, this is a much better solution than one.
That's really a great point. You can say that if you want all the benefits of a Class A amplifier and you live in a warm climate, this is probably the only amplifier that you can practically use. So anyway, it's a great solution. So let's talk about just a couple of things here. We have active cooling, the intelligent cooling tunnel. It's an aluminum tunnel that goes from the front to the back of the amplifier. There's an air intake on the front. If you put your hand on the front, you'll feel cool air coming in. If you put your hand on the top cover, it's room temperature. It doesn't get hot at all. And then if you put your hand behind the amp, you'll feel that the air is warm, but it's not blowing on your hand. You can't feel any wind. You just feel that the air is warm. The temperature is warm back here. And what this shows is that the fan is moving air at a relatively slow speed through the system, so that you're not generating noise either from a fan or from the air intake. So the whole system remains extremely quiet. The air intake comes with a filter. So you can vacuum clean or remove it and wash it. It's held in place magnetically. And the louvers on the front have a kind of an aerodynamic shape in order to promote a smooth flow of air through the system so that it doesn't generate noise.
Now, Dave, the thing about that, we talk about build quality, that removable vent or with filter is not made out of plastic.
That's right. So it's aluminum. That's right.
Yeah,
It's all
everything you touch
anodized.
on this thing, it's all quality. There's a level of quality to this thing that is absolutely insane. Also, as he takes the lid off, this to show you the kind of the crazy fit and finish. If he'll show you later the meter, the edge of if you notice the case has a rounded edges. In order to blend that meter into that case, the meter
Right
actually has
here.
a rounded edge. You know, the attention to detail to make it that clean and that smooth is crazy. Okay, so let's look inside this thing.
I'll just move a little bit closer here. So you see the transformer on this side of the chassis. It's mounted in a vertical orientation, which is particularly nice because the noise fields are now in the vertical plane. Toroidal transformers are used in high-end amplifiers because of the way they contain electromagnetic noise. So this starts off as a very quiet type of transformer, but its orientation further eliminates any possibility of electromagnetic noise getting into the audio circuitry. You see the aluminum tunnel here that runs from the front to the back. I have one taken out of the chassis, which I'll show you in a few minutes so you can have a closer look at it. You see there are 4 lateral MOSFET packages. There are 2 transistors per package, so 4 on each side, which combines to a total of 16 output transistors. If we could remove the tunnel and flip it over, we'd see the same complement on the bottom. So there are a total of 32 output transistors. We use a special kind of filter capacitor. You can barely maybe see here and here, but also underneath the control board, two layers of circuit boards that contain filter capacitors, storage capacitors from a German company called Mundorf. These are special 4-pole Mundorf caps. A 4-pole capacitor is one that can discharge extremely quickly and refill extremely quickly. It's also, no surprise, an extremely expensive component. It's a big part of why this amp costs what it costs.
So Dave
Yeah,
has the
yeah.
IC
Just
tunnel.
a very quick view of the IC tunnel. You see on one end of it, you have the fan for the air intake, which is a bit thicker than in the previous generation. So each revolution scoops more air, and that helps us move the air through without spinning the fan faster. Then you see that it's 2 aluminum extrusions that get put together. There's a damper in the middle so that the fins do not ring. There's a lot of aluminum to pull heat away from the transistors, and then the fins are designed to give us as much surface area as we can get inside, which implies a lot of fins, but you can't have so many fins that they are close together and heat each other up. So it's a design which calculates how thick the fin should be and how close they should be together to optimize the performance for our particular design.
Okay. The other thing too, Dave, you mentioned when you flip it back over, you say that the fan runs at a lower speed because of the way the blades are designed, and that when you put your hand in the front of the amplifier, you don't feel air being sucked in, and when you put your hand in the back, you don't feel like it's being blown out. Because one of the things people see when they think fan, they think noise, and this thing is the speed of the fan and the way the system is, it's pretty much silent.
Yeah, you wouldn't find these amplifiers in recording studio applications. Our previous generation, which did create a bit more noise, everything creates some amount of noise. It's whether it's a problem or not. And so the previous generation, which had more noise than this, was used in or is used in recording studios. So most recording studios are quieter than most consumer listening environments.
Another thing that's kind of interesting about this amplifier, and as you mentioned it, the positioning of things are different. So if you pull the lid off of most amplifiers, as Dave mentioned, the toroidal would be in the middle. And he talked about the benefit of it being mounted this way instead of that way. But they normally have to put it in the middle. Why have to put it in the middle? Because along the outside, they have to put the transistors connected to fins or cooling fins to keep to dispel the heat. So that, which is why you normally see fins on the outside of an amplifier and the toroidal in the middle. But because of the way this amplifier is designed, the cooling and the transistors are actually in the middle, and the toroidal is actually on towards the outside. So it's like, literally the way that the amplifier was designed completely changes the layout of how you would normally do an amplifier, and that's what makes it really efficient and can generate this amount of power and current. So hey Dave, I
Yeah,
know I'm looking, the questions are starting to come, so I'm gonna give Frederick an opportunity to ask you a couple of questions while and then we will go and talk about some of the other things that are going on inside and also in the back of this amplifier. Okay,
sure.
so go ahead, Frederick.
Okay, so we have a question, first question from Seneca, and he wants to know about the damping factor of the amplifiers and also if it's adjustable or not.
The damping factor we rate at greater than 700 across the entire audio band. Most of the time when people give a damping factor, it's at a particular frequency, whichever is most beneficial to the number. And greater than 700 is, in our view, it's more than enough for all practical applications. It is not adjustable. It's a feature of the output stage of the amplifier.
Okay, and then another question from Balaji Ramachandran wants to know if this a switch to switch the impedance, or is it done automatically based on what speaker load it's basically detecting?
There's no switch to align the amplifier with the loudspeaker impedance. There are some amplifiers that do that. Typically, if you have an output transformer, you'll see that. The problem, or the thing about that, it's a really good question. The power rating becomes very misleading for people. So let's say we have a 300 watt amplifier that has different taps or switches for 8 ohms, 4 ohms, and 2 ohms. If we say that this 300 watt amp is going to be connected to a low impedance speaker, so we choose the 2 ohm taps, we're going to deliver 300 at 2 ohms, but we're not going to deliver 300 at 8 or at 4. At 4 ohms, we'll deliver 150 or less. And at 8, we'll deliver 75 or less. So the Ohm's law calculation has to be done in reverse when you choose a tap or a switch setting that's lower than 8 ohms.
Yeah, but unlike our amplifiers, when we say when you're saying 300 watts in the 8 ohm, it's 300 watts in the 8 ohm, and when you go down to 4 ohm, it's going to double. When you go down to 2 ohms, it's going to increase again. So the
Yes.
fact that there is no taps means that you are going to get at least 300 watts, and as the impedance goes down, you're going to get more. The other ones, you're going to get 300 watts at the tap, and if the impedance is higher, you're going to get less. That's not a good thing. So you can't compare. So it's really difficult to compare the two. So this is actually a more efficient way of doing it, but it requires more current, which makes it heavier and makes it even more expensive. So this way is the hardware. The little transformer probably would require less of a current demand, because all you're doing is what is that transformer doing? The step transformer, the taps. What are you doing with that, by the way, engineering wise? Is it just like a resistor or something? What is it doing to actually to do that?
Well, it does depend. It depends on the amplifier design, but you can think of it as impedance matching and form of protection. The fact that it's coils that are in the system in between the output stage and the loudspeakers, to our way of thinking, it introduces some level of compromise. And like there are always compromises in designs, so it's just one that those designers chose to make. So we don't really pass judgment on it. It's just not something we would do.
Okay, okay. But like I said, it's a different approach, and it's really difficult to compare the two different ones. It's because you have to look at all of the specs, in order to see it. So if you look at the one,
Yeah, I would say there's one. If you don't take away anything else from this session, the one thing you should take away is that you should. I'll say two things. One is you should view specifications with a degree of skepticism, and you should not compare the specs of one brand to another, because they are rarely made under the same conditions. So it's okay to compare specs within a line, within a brand, because they're typically made in the same way from one to the next, but not so much when you go from one brand to the next.
Yeah, and hopefully at this price point, you would take the time to go listen to it before you make this
Yeah,
type of investment.
exactly. That's
So
what you should do.
so
That's
a big
that's the ultimate specification.
Okay, Frederick, do we have any more questions? That was actually a good one.
No, not specifically. Somebody was asking about support if your amplifier gets faulty in Africa, but I already replied that we do support worldwide. We have distributors worldwide and partners. So if there's an issue, we can definitely support that, and you can buy and sell with a good conscience. No worries about that.
Exactly. And so good question so far. So as we talked about, it's unique looking on the inside, and it's very unique looking on the outside. The intake is unique because of the icy tunnel. Also, there's some things about it, if you look at it cosmetically. The rounded edges. Is that case made out of plastic, Dave?
No, it's a single piece of aluminum that as
Wraps all the way around, right?
it starts in the corner here and wraps around to the corner here. We actually call it the chassis wrap because it does wrap around the chassis of the unit. There was when we decided on the industrial design, we did some experimentation to see how it performed mechanically. We take vibration, mechanical vibration, seriously. We don't like to introduce vibration inside where there are thousands of components. If they vibrate, they're moving relative to each other, even a tiny amount back and forth, and those movements generate tiny little signals. And when that all adds up, it adds a kind of a haze or a loss of clarity to the signal. So we're very conscious of vibration. And this curved front of the chassis helps to eliminate a resonance that would otherwise be set up in a conventional rectangular box.
Yeah. On top of that, Dave, even the feet are designed to help eliminate vibration, because you use different densities of feet depending on what product you buy just for that, right?
That's correct. These are from a company called Navcom. And if you looked at the foot on the bottom of a preamp, you'd see that it was relatively soft compared to the foot on the bottom of an amplifier, because the amplifier weighs a lot more than the preamp. So the material is formulated to provide the best isolation depending on the weight of the product.
Exactly. So fit and now the other thing too, we talked about the fact that the front of this amplifier looks really unique, but also the back. There's some things you want to talk about when we talk about quality. When you first told me about these, I was kind of like, wow, what is that? But Furatech Torque Guard speaker connectors. So these are the connectors on the back of this amplifier. Can you talk about what those are?
Sure. The material that's used for a speaker connector on most amplifiers is it's usually something like brass, and the reason is it's chosen because it's hard enough to accept a torque wrench or something, not a torque wrench, sorry, a socket wrench, customers like to tighten the speaker connectors really, really tight. And the problem with brass is it's not a particularly great conductor. It doesn't sound that good. Ideally, we'd use copper. And the problem with copper is it's not as strong as brass. And so if you want to use copper, you have to have a way of making sure that you don't over tighten the connection, that you get it the proper amount of tightness, but no tighter. So that's where torque guard comes in. These are copper binding posts that have a special type of connector attached like a torque wrench, so that when you tighten it, it only gets to the proper amount of tightness and no more. So it's like a torque wrench. Now, you have, if you're going to use copper, just like on an RCA connector, you can't leave the copper bare because it will corrode. So you plate it with something, and you often see gold plating on connectors. That's the most common type, even among relatively inexpensive components. And gold looks nice, and it implies a certain level of expense, and it won't corrode. It's a precious metal. It's not very durable. It scratches really easy because it's super soft. But the problem with gold really is that it cannot be plated directly onto copper. You have to have a barrier metal in between, usually something like nickel. So the gold connectors that you see on most components, you think gold is a great conductor, and it is, but when it has to go through nickel to get to copper, it's not so great. So the better solution is to use rhodium. Rhodium is the rarest of precious metals. It costs more than gold. It can be plated directly onto copper, and it's extremely durable, so far more durable than copper. So it lasts more than the lifetime of the product. So while being expensive, it really is the best solution. You'll see that on the RCA connectors as well as the speaker connectors, and on the preamp as well, as you see there on the screen.
Exactly. So rhodium plated connectors and rhodium plated Ferritech torque guard speaker connections. Now, we talked about this before. This is actually kind of important about these particular speaker terminals, because the amplifier is a big investment, but also the cables that most people are using to connect this amplifier, people are actually spending a good amount of money on. And so these speaker connectors also not only protect the amplifier from you over tightening, but it protects your very, very, very expensive AudioQuest Kimber cable, whatever wires you're using, from you over tightening. You get the perfect amount of torque or tension or connection without the risk of damaging your high-end equipment. So it's cool. It's a cool solution, and they're not inexpensive. They are definitely cost more, but if you're buying at this level, it's important. So this is actually the back of a Delta stereo. Now there's a couple of other things back there. There's a whole bunch of looks like almost like a switch. What are all those things over to the left that look like that have like network connections and USB connections? Can you go over those real quick?
Sure. There's an Ethernet connection. You can connect the amplifier to your network and see the amplifier. There's a web page, and from there you can see if any of the protection circuits have been engaged. You can see which ones and some of the conditions, and help troubleshoot what might have happened. You can also control the amp. It's not obviously a very complicated product to control. You turn it on and off. You could mute it. You could change the brightness of the meter lights and so on. But anyway, Ethernet control. You've got RS-232, which is also an older form of connector for controlling the amplifier. There's a pair of CAN bus connectors. CAN bus is a controller area network bus. It uses ordinary network cable. And if you connect all the Class A components from one to the next, using CAN bus, then you can control them. Like for example, you turn one unit on and the whole system can come on. You turn one unit off and the whole system can switch off. Also, if you've got a preamp connected to the amplifier, and if a protection circuit is engaged, it's possible to look at the protection history using the touchscreen of the preamp. So it's a pretty cool and easy to use interface. And then of course DC triggers, and there's a switch for auto standby. If you want to disable the auto standby function, you can do that from the rear panel. One thing real quick before I move over, I just want to mention that we also provide a special AC cable.
Oh, I forgot about that.
This is a DR Acoustics power cable that was
designed. Let me bring that. Let me. How much is that power cable? That power cable is high quality.
So if you sold that separately, you'd be competitive with $2,000 power cables, but it uses Furatech connectors and prevents the unit from getting prevents the wires from heating up, so it doesn't get in the way of delivering current.
Yeah, so it's so a lot of times people ask us, do cables matter? Yes, they do. If you want good quality cables, and to show how much care they take, they include a cable. The power cable would cost hundreds and hundreds and hundreds of dollars just by itself. So could you buy a better one? You can, but the goal is there's no guarantee that you will. And Dave wants to make sure you get the most out of the amplifier, so they include a very, very high-end power cable with the amplifier. So I'm glad you brought that up. That's another example of attention to detail. So Frederick, questions while Dave swaps over.
Yes, absolutely. We can start with a question from Arun. He's asking about why has Classé, after the Sigma series, which were obviously Class D, Classé went back to Class A amplifiers. So what's the reasoning behind it?
Well, the Class D amplifiers were developed to reach what we believe is, a Class A level of performance at a much more affordable price. Once we put the Class D amplifiers into the market, we thought, well, okay, now that we've addressed that, we can revisit linear amplifiers and go to an even higher price, which is where the new Delta series is. Then when Sound United purchased Class A, their view was that they didn't really need Class A to be competing directly at price points where Marantz might be. They needed us to explore the premium categories. And when you spend more money, the Class A and quality Class A/B solutions, linear amplifiers, we think outperform Class D.
And Balaji is also wondering, would you introduce an integrated amplifier, or is that something on the roadmap, or would you just stay with separate?
Yes, it is on the roadmap. We have a 5-channel power amp, surround processor, and a stereo integrated. It'll be some time before these are available. They're all what we would call ground up designs, so they're not just modifications of an existing design, but they're really starting from scratch. And so the development lead times are pretty long, but we're working on it, yes.
We got a very interesting question from Andre. The fact that we now partner, or that Classé is under Sound United, we have technology that we can share. So what's the likelihood of seeing integration with a HEOS chip in Classé, for example?
High.
Very high. Yeah, and that goes back to what we had talked about before, Dave, about your engineers in Montreal can focus on that beautiful amplifier topography.
You don't want our guys, exactly. You do not want our guys trying to deal with Wi-Fi network related things. You want us doing audio, and so that's why it's it's a great partnership.
Yeah. like I said, Volkswagen, the airbags in a Lamborghini are built by Volkswagen. Why? Because let the Lamborghini engineers make motors and bodies, and
Yeah.
suspension, and let the things that you would like to make, that you would expect, Wi-Fi capability, streaming music capability, let the big mother company work on that, so the engineers can assign their resources to the things that are truly that make Class A sound like Class A. So
Great.
Dave, thank you
My pleasure.
for coming again. Hopefully you guys have learned a lot. And for everyone who came and hung out with us today, thank you again. And we will talk to you soon. Bye-bye.